sum of prefix scores of strings. So let's first try to understand the problem. So we are given an array of words. So inside words, there's a single word. So for example, ABC is a word, AB is a word. Yeah. So the size is it is the non-empty strings. And we define the score of the string word as the number of strings word I, such that word is a prefix of words I. It's difficult to understand. Yeah, basically, if there's no examples. Let's just take an example. So we have a words array. It's like that. And the score of AB, let's just check the score of AB. So the score of AB, we just check this AB. So it's going to be the number of prefix. So how many numbers of words with a prefix of AB? So this is a 1, and this is another 1, so it's going to be 2. Yeah. So we're going to return the answer of size n, where n is I is the sum of scores of every non-empty prefix of words I. So we have to understand this one. Yeah. So what's going to be its answer? The answer is I. It is the sum of scores of every non-empty prefix of word I. Let's just try to use an example. So for example, we have ABC. So what's going to be the score of ABC? It is the sum of scores of all prefix. So what is the prefix of ABC? It has A, AB, and ABC. Yeah. So what is the score of A? So for A, this is a prefix. Another prefix, it is a 2. What about AB? This is a prefix. This is another prefix. It is also 2. What about ABC? This is a prefix, only 1. So it is 1. So 2 plus 2 plus 1. So the score of ABC is going to be 5. So this is why there is a 5. Now I think we have some idea to solve the problem. Let's check. The word.length is 1000 and word I.length is 1000. So it means we cannot solve the problem by the brute force. So the brute force idea is that we're gonna turn these words into a set. Yeah. So into a set. So inside the set, we're gonna just use the brute force to solve it. So first of all, we're gonna turn the words into a set. Now inside this set, we're going to enumerate all the possible cases. So for example, for ABC, for enumerate all the cases, it's going to be n squared. And then we're going to check each of the case if it is inside a set or not. If it is a start, for each word inside of the set, we're going to use a starts with. If it starts with that word, maybe maybe we're going to just count it. Let me use an example. So inside of the set, maybe we have ABC and we have AB. Yeah. Now for this n square, it's a nested loop, but maybe inside of the n square it has a case of AB. Now we want to check each one of them. So for ABC, if it starts with AB, for AB, if it starts with AB, so it is another n square. So actually it is n squared times n squared. It's going to be n to the power of 4. Definitely we cannot solve it like that. Yeah, because this n is just 1000, it means it's not possible. But we can use another data structure. It can be easily used to solve such kind of problem. So it's going to be a trie. Yeah, now let's just use the idea of trie. So for the trie, from the beginning we have a root node. So this is a root node. And now we're going to have some characters. So for example, we have character A, and this is a B, and this is a C. And for this one, this is a AB, it is here AB, and another one is BC, so this is a B, and this is a C. So another one, it is a B. Yeah, but for all others, I don't need to check. I just need to use this example. Yeah, but even for this example, we can not only prepare a trie, we cannot only prepare to insert. We cannot only insert the word one by one, but we can also prepare a counter. So for ABC, while we insert A, we have a count as 1. And while we check this B, we have a count of 1. And for C, we have a count of 1. Now we're going to insert AB. So while we insert AB, so this is A. So the counter is going to plus 1, 1 plus 1. And then we're going to insert B. So it's going to be 1 plus 1. Yeah. Now we're going to insert BC. So for BC, we insert B from here. It's going to plus a 1. And for C, it's going to plus a 1. Now we're going to insert B. It's going to plus a 1. Yeah. So now we are going to check. So what about we check ABC? Yeah, I'm just going to use one example. So for ABC, first of all, I'm going to check A. So for this A, what is the counter? It is a 2. Yeah. So what is AB? So for this A and B, it goes to here. So for AB, it is also 2. So what about ABC? This is ABC, so it is 1. So it means 2 plus 2 plus 1, it is 5. So this is why we can use a trie to solve the problem. Yeah. So for preparing the trie, we just need to check each of the word and insert it one by one. So this is going to be n squared. And after preparing the trie, we just need to check each of the word. So for example, this is the word ABC, and we just need to check each of the character. So this is also n squared, but the time complexity is going to be n squared plus n squared. So that is why the final time complexity is going to be n squared. That is why we can use a trie to solve such kind of problem. Yeah. Let me just maybe just copy some trie template code, and then I'm going to change a little bit. Yeah. So I believe if you know a little bit about trie, definitely you can find some template which can, some template of trie. So let me just copy some trie template and delete. So basically, I don't need to use the search and start with, but I need to prepare a counter. So for the trie, I'm gonna prepare a trie node. So the trie node is just has children and add of word, but for our problem, we don't even need to have the add of the word, but we need to have a self.count. Self.count gonna be starting from 0. Yeah, and the trie node also have children, so the children can be 26 English letters. Now we're gonna prepare this trie. So we're gonna prepare a root. Self.root gonna be equal to this trie node, and then we're gonna have the insert. We're gonna insert the word one by one. Let me just change something maybe. So I have a count. Yeah. Now if I were to insert it, so from here, this is the self.root. This is my trie node, and then I'm gonna insert each character inside the word. So for example, ABC, I'm gonna insert A. So if it's not inside the current.children, I mean the root.children, so I'm gonna prepare a trie node. So I'm gonna initiate a new trie node. So the current.children with this character C gonna be equal to a trie node. Yeah. So for the next, no matter if it is inside or not inside, currently I have a children, so the current gonna be equal to the current.children. So for here, at the add word, I don't need to take care of that because I don't need to check if that is a word or not. I just need to have a counter. I think this is okay. And after that, I need to prepare a current.count. So if I insert a letter, I need to count it. So the current.count would plus equal to 1. Yeah. Now this is the only preparation I need to prepare. I need to do. I'm gonna prepare a trie node, and I'm gonna initiate and prepare an insert method because later on I'm gonna insert the word one by one. Now let me prepare the trie. So t gonna be equal to the trie, and we're gonna check the word. So for word inside the words, let's just insert it. So t dot insert each of the word. So while we are inserting the word, we also prepared the counter. So we're gonna prepare the counter to here. Let me explain why we need to prepare such a counter. Yeah. So normally this is a trie data structure. So for example, if this is a character C, let me starting from here. So from here, this is the root node. So for the root node, we have children. So this is a children. It's a dictionary, and it also has something maybe. For our example, it has some children. It have a count. Yeah. So for this node, it has a count, but currently it is a 0. Now we are going to insert a character, maybe A. So if this is a character A, yeah. So we're gonna first of all we're gonna check this character if it is not inside the current.children. So this is my current. It is a root node. So this is the current.children. Currently it is empty. If it is empty, what I'm gonna do? So I'm gonna .children with this character gonna equal to a node. So I just prepare a k-value pair. So k gonna be this character A, and yeah. So the let me try to explain in this way. So the current.children C is just it is another node. Yeah, so the current.children C gonna be another node. So this node gonna be initiated as a new trie node, and inside it has a children. So this gonna be the children. It has also have some variables like the count. It has also have a count. Yeah. Now, first of all, we prepare this character with this trie node. Now we're gonna assign the current to its children with this character. So it's gonna be current.children with this character. So this is current, and this is current.children. Yeah. So the children gonna be current.children gonna be this character A. Yeah. So for this character A, I'm gonna assign a children. It also has a children because it is a trie node, but it also have a count. So the count. So finally, I'm gonna have this count plus equal to 1. This is why I'm gonna write it here. I think here is a little bit difficult to understand. Yeah, because basically we're gonna have a root node. The root node has a count. Yeah, but after the root node, we also have some other characters. And after the root node, we're gonna have the characters. So for the characters, we have some properties. We have the count, and we also have the children. So for the count, we need 2 plus 1. So from here, the current from the beginning, we're gonna prepare the current.children A gonna be the k, and the value gonna be an empty dictionary. And now for the second step, so I'm gonna assign my current to its children and gonna be to this character A. So while A has some property, it has a count. So current.count would plus equal to 1. Yeah. So this is a node. And while we are going to this A, this is another node. It is its children. Yeah, we have to understand the data structure of trie, otherwise we cannot solve it so easily. Now, after inserting the word, we just need to check the final answer. So I'm going to prepare a result array. It's going to be 0 times the length of the word. I'm gonna check each word, so inside the words, and I'm gonna prepare current. It's gonna be t dot root, and I'm gonna prepare a root, and I'm gonna prepare an answer. So this is the sum of the each. This is the sum score of each prefix. So for example, the sum of A, AB, and ABC. The answer is going to be starting from 0, so I'm going to check each character inside the word. Yeah, so for each character inside the word, so the current from the root is going to be equal to the current.children with this character C, because we are sure it must have this children, it must have a character C, because we've already prepared the trie. Yeah, because we've already prepared everything, it must inside. Now we just need to accumulate the score. So it's going to be the current.count, and the result I going to be equal to the answer. And finally, we just need to return the result. As you can see, the coding, there's not so much coding. And basically, we just need to copy this template and change a little bit, like this count, and we're going to prepare the count here. Now let me just run it. Yeah, I need to use enumerate. So for I word in enumerate words, inside the enumerate words, now I can use this index I. Now as you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and I think it's pretty fast because it's nearly 85% of our submissions, even though it is 2 seconds, because normally for the trie problem it takes time. Yeah, because we prepared like the trie node, it is a class and it is another class, and for this trie node, for each of the function call, we code so many classes. But in Python, while we are coding a class, it really takes time. And also while we are using a hash table, it really takes time. So that is why it is like 2 seconds. And also because the time complexity is n squared, 1000 times 1000, that is why it is so slow. I think that's for it. Basically, this problem is a very basic application of trie. If you know what is a trie, basically you can solve the problem. Because for this kind of structure, so for this is a trie node and this is a A, we're gonna accumulate the score like one by one, and this is a B. I think this kind of a process is not so difficult. The difficult part maybe after a long time, if you didn't solve the trie problem, you might forget about the template. You don't know how to write the trie template. So that's for it. Thank you for watching. See you next time.